is August 30th, and I'm doing Geometry Pre-AP notes. Our notes today cover angles and angle addition postulate. So the first thing we need to look at is the definitions page that I gave out to you. If we look at our definitions here, the first definition you will see is an angle. An angle is the measure between two intersecting lines, rays, or segments named with 1 or 3 points. That's your biggest and most important part. It's named with 1 or 3 points in no specific order except for, this I would underline, the vertex is in the middle of the name. You mark it with a flattened less than symbol. That's the symbol for angle. Note, you can only name angles with a single letter if it will not cause ambiguity. Meaning, if there's more than one angle with the same vertex, so if more than one angle with the same vertex, you have to name it with 3 letters, aka points. Okay? And that vertex better be in the middle. If you look over here, how do you name angles? It's the angle symbol with either B, that means there's one angle at B, or you can name an angle ABC. If you look over here, here's a triangle. Here's all the names of all the angles in this triangle. Now, you've heard me use the term vertex. I hope we all know what the vertex means. The point where 2 or more lines, rays, or segments intersect. Okay? When there's more than one angle at a vertex, you must use the 3 letters to name the angle. This again is just reiterating what I said up here. If I look here, my vertex for this picture is E. E would be my vertex here. And it's the vertex of the intersection of segment AB and segment CB. Okay? So we all know what a vertex is now. Now, when you have the angle symbol and you have a little M in front of the angle symbol, that specifically says the measure of the angle that they've named. So if I look at this triangle here, the measure of angle 1 would be 79.4 degrees, as written here. Measure of angle BAC, well, what's your middle letter? A. Again, vertex A, 79.4 degrees. Congruent angles simply means they have the same measure. So, you mark congruent angles with an arc or multiple arcs, depending if you have more than one set of congruent arcs. For example, look at my picture here. Angle ABC and angle FED both have one arc, so these two angles would be congruent. Angle IHG and angle KJL, both, they have 2 arcs because they're not the same as these 2 angles, but they are congruent to each other. Interior sounds like interior design. What do you design when you're in interior design? You design the inside. So the interior of an angle is the area between the 2 lines, rays, or segments that make up the angle. For instance, on this diagram here, D, point D here, is in the interior of angle ABC. It's inside this angle. An angle bisector, well, we know what bisector means. Bisector means it cuts it in 2 equal halves. So an angle bisector is a line, a ray, or a segment that cuts an angle in half. Just like with segments, you bisect it, the 2 halves are equal to each other. As you notice on the diagram here, BD is your angle bisector. And if you look, we have the arc measures to prove that this angle, CBD, and angle DBA are congruent to each other because segment BD bisected the big angle ABC. Another definition you need to know is adjacent angles. Adjacent means next to. So adjacent angles share a line, ray, or segment. Good example is the picture over here. Angle BAC and angle CAD are adjacent angles because they share segment CA. This right here. They share a side. Now let's talk about some things that you should have heard before, but we're going to reiterate. Supplementary angles, those are angles whose sum is 180. How do I remember supplementary? The S makes an 8, so it adds up to 180. Okay? Complementary angles add up to 90. How do I remember that's 90 and not 180? The C in complementary makes, if you take the line straight down, makes a 9 for 90 degrees. So supplementary angles, they could be adjacent or they could be non-adjacent. So please make sure you understand that. They can be adjacent or not. The same thing goes for complementary angles. They can be adjacent or non-adjacent. Supplementary adds to 180, complementary adds to 90. Now, vertical angles. Another definition that is very important you understand. Vertical angles are two angles made by crossing of two lines, or segments, or rays. Well, not rays, but lines. The angles share a vertex. They share a vertex, very important, and they have the same angle measure. So, vertical angles, they have the same measure, are what we call congruent. So when we mark it on a diagram, say right here, the intersection of segment AB and segment CD is E, you have vertical angles of angle CEA and angle BED. They have the same measure. Basically, they make two V's that have the same vertex. Your next definition is linear pair. A linear pair is two supplementary angles that are also adjacent. Okay, so a linear pair is a set of supplementary angles that are adjacent to each other, so they share a side, such as this diagram right here shows you. And because we know a straight line equals to 180, the two angles on a linear pair should add to 180. Okay? Okay. I don't want to spend a lot of time on these because y'all should already know these. Acute angle, less than 90. Right angle, equal to 90. Obtuse angle, greater than 90. And a straight angle, which is a line, is 180 degrees. Now let's take a look at your homework. Let me adjust something really quickly. Your homework states to draw, this is the angle addition postulate half sheet that you picked up today. It says that draw and solve the following. Well, they only gave you one diagram, so yet again, my advice to you is draw it every single problem. Then they tell you ray AL bisects angle KAT. So here's angle KAT, it bisects, so I know that angle 1 and angle 2 are congruent, because bisects means it cuts it into two congruent angles. And they want us to find the value of x. So number 1 states that the measure of angle 3 is 6x, so label that on your diagram, 6x. And the measure of angle KAT, so this whole angle right here, is 90 minus x. They want us to solve for x. What do I know about these two parts that they have shown me? If it's hard to see, maybe taking a highlighter and highlight angle 3 here. Here's angle 3. Sorry, that wasn't very neat. And then highlight angle KAT. What do you notice about these two angles? Well, they're adjacent, right? And they form a linear pair. So they're a linear pair, which means they are supplementary, which means they add to what? 180 degrees. So I would add angle 3, the measure of angle 3, plus the measure of angle KAT, and set it equal to 180. So 6x plus 90 minus x equals 180. So I get 5x equals 90. So x here turns out to be 18. Okay. Now let's look at number 6. Uh-oh, again, having troubles with my picture. There we go. Alright, again, they told us that AL bisected, so I know angle 1 and angle 2 are the same measure. They tell me angle 2 is x plus 12, and they tell me angle 3 is 6x minus 20, and they want me to solve for x. So the first thing I do is I look. Angle 2 has a congruency arc, which tells me that angle 1 is exactly the same as angle 2, so I can mark it as x plus 12. Now, looking at this, all three of these angles make a straight line, so they all add up to 180. So angle 2 plus angle 1 plus angle 3, the measures of those angles, don't forget the little m in front, should equal to 180. So angle 2 is x plus 12, angle 1 is x plus 12, and angle 3 is 6x minus 20, and it should equal to 180. So that's 1, 2, 8x. 12 and 12 is 24, minus 20 is 4, equals 180. So 8x is 176. So x would turn out to be 22. Okay? Now, it's your turn to try and draw some angles based on the definitions we just went through, and to try some of the angle addition on the angle addition homework.